Alright guys, in today's video we're going to be looking at the attributes of rational functions. Rational functions, if you remember, are functions that involve having a fraction where that x value is inside of the denominator here. In these rational functions we've got a new attribute that we hadn't seen before. It's called an asymptote. An asymptote is a line that the graph approaches but it never really touches. In this particular graph, it actually has an asymptote right here at x equals 3 that it actually approaches. It looks like it touches, but it actually never really touches this line. It also has a horizontal asymptote right here at y equals 2. Okay. So that horizontal asymptote again is found at y equals 2. And our vertical asymptote is found at x equals 3. You may notice that these numbers align with the c value and the d value here in our function. Okay. If we plug this in the calculator and do a little tracing like we would normally do, we'll find that the x-intercept sits at 2.50. That's going to be this point here where it hits the x-axis. And then this point here where it hits the y-axis, that's our y-intercept. And again, if we trace this on the calculator, we'll find that's at the point 0, about 1.7. Now, we're going to concentrate just on interval notation here on these new types of functions. If we look at the x values, the domain, again, remember the domain is our x values. Well, the lowest x value this has is off the graph here. You know this keeps going forever. The lowest x value is actually negative infinity. Okay? Now remember this asymptote, it never hits, so we actually skip over that value of 3. So it's going to approach the value of 3. And then we signify a union, and we start over at 3 again, signifying that it kind of skips that value of 3. And then notice over on this side, the x values keep going this way to positive infinity. Okay? Now if we look at the y values, our lowest y value, this line is going to keep going down forever. So our lowest y value is negative infinity. We approach that asymptote at y equals 2. So we reach y equals 2. We don't really touch it. Then we sort of jump over that 2 value. And then it continues going up on our y values there to a positive infinity. Notice this 3 and this 2 correspond to our vertical and horizontal asymptote. Alright, let's look at our second example. In our second example, we can look at our graph, or we can look at our c and d values to get our asymptotes. You'll see the horizontal asymptote. Okay, the horizontal asymptote sits right here at a value of y equals negative 3. Our vertical asymptote is going to sit right here at a value of x equals negative 1. Our x-intercept, which again we can use the calculator to find, is going to be at negative 0.30. That's right here. And our y-intercept is right there at 0, negative 1. Now our interval notation for the domain and range of this, our x values go all the way down to negative infinity. Remember, they're going to jump over that asymptote value, so it's going to go to negative 1, not touch negative 1. Then it's going to pick up again on the other side of negative 1 and go to positive infinity. Our y values are going to go all the way down to negative infinity. It's going to sort of skip over that value of negative 3. And then it's going to continue on to positive infinity. Okay, let's look at our last graphing example here. Again, we can focus on the graph or we can focus on our equation. So we can focus on the graph and see our vertical asymptote there at x equals 4. Or we can see our horizontal asymptote sits right about here at y equals -1. Okay, so our horizontal is at y equals -1, and our vertical is at x equals 4. Okay. Notice those values are also found right here in the equation. All right, our x-intercept, we can look on the graph here. It's right there on the x-axis at a value of 2, 0. And our y-intercept is right here, which happens to be the value of 0, -0.5. Now let's look at our interval notation for this one, for the domain and range. Okay, so again, our x values, they're going to start at -infinity. They're going to approach that value of 4, but not touch it. Then they're going to pick up again on the other side of 4 and go to +infinity. Now our y values, they're going to start at -infinity. They're going to approach that value of -1, but not touch it. Then they're going to jump over that value, pick up on the other side of that value of -1, and approach +infinity. Okay, so those are the attributes that we're going to be looking at for these rational functions. Let's look at some transformations now. Now you will notice in our general equation here, we still have a, b, c, and d, just like we did in our other equations. And the transformations of those are actually exactly the same. We are going to look at these a little bit different now, though. We're going to look at how an equation is changing from one function to another. Okay? So here would be like function 1 to function 2. What is happening here? All right? Well, if we look at the changes in this particular example, we can look at our a value. Our a value is changing from 1 to 3. Okay? Well, anything greater than 1, if you remember, is a vertical stretch. So we've got a vertical stretch happening to this function. All right, so let's look at number 5 here. Number 5, we've got a couple things going on. We've got a changing from a value of 1 to a value of 0.4. Okay, so our a value is getting smaller. It's actually a value smaller than 1. So we've got a vertical compression happening here. Okay, we've got one other value changing here. We've got our d value. Our d value, from a 0, there's no d value here. Okay, there's a +0 there. It's changing from 0 to a -5. All right, if you remember, a negative on the d value or subtracting on the d value is a shift down. So it's shifting down 5. All right, so let's look at number 6 now. Number 6, our a isn't really changing values. It's changing from 1 to a -1. If you remember, a negative on the a means it's going to reflect over the x-axis. Okay? We've also got one other value changing here. This time it's the c, which is inside that denominator. Our c goes from 0, because remember this is x plus 0 here, there's no value there, to a +4. Okay? Now our c, if we're doing a positive, if we're adding, you have to remember that's a shift to the left 4. All right? Let's look at number 7, which actually has the most going on. All right? Number 7, you're going to see our a value actually does a couple things. It goes from 1 to a value of -5. All right? Well, if a is turning negative, that's going to be reflect over the x-axis. Okay? And then we've also got it changing from 1 to 5, which is increasing. It's getting bigger than 1. So that's going to be a vertical stretch. All right. So now let's also look, we've got our C value here. Our C value is changing from a 0, minus 0 is the same as 0, to a negative 2. Okay. Well, you got to remember subtracting on the C. Subtracting is a move to the right. So it's moving right by 2. All right. The last change we've got going on this one is our D value of 0 is changing to a value of positive 8. A positive on the D value is a shift up. So we're shifting up 8 on this one.